Hi, I'm Wayne Leck. This is January 2013 Core 3 for AQA. It's question 2. According to my examiner's report, it's split into A and B, this question, and in part A, it was more commonly arithmetic mistakes and silly errors rather than understanding. And part B, some rules were not quite known well by some of the students, although most of the time it was generally done very well. So we'll turn to the whiteboard and go through part A and B of question 2. So, question 2, there's an A and a B. A is probably going to take up quite a bit of room, so we'll do B on the next whiteboard. So A, use the Simpsons rule with 5 ordinates or 4 strips to calculate an estimate to the integral between 4 and 0 of x over x squared plus 2 by dx to 4 significant figures. So, it tells you in the question to use the Simpsons rule. So a good first step would be to write out the Simpsons rule. It's in your formula booklet. But it might be useful just to write it down, and you might even get a method mark if they're being generous. So it's y0 plus yn plus 4 lots of y1, so on to yn minus 1, plus 2 lots of y2 all the way up to yn minus 2. So that's just quoting the formula that's in your formula booklet. You may well get no marks. But in some past papers they do actually be generous and give you a method mark just for selecting a right equation. So that's friendly. First step with all of these sorts of things is to work out h, which is b minus a over n. You should know it labels at the beginning of an integral with b at the top and a at the bottom. So we know it's going to be 4 minus 0, our 4 from here, minus our 0, over n. N is the number of strips, and it tells you in the question 4. So our h value is 1. So we know that outside the final thing we're going to have a third times 1. We know we're going to have that. Now the question is what goes inside the bracket. So what I like to do is I like to look at it between these points and zoom in a little bit. So we're looking in between 0 and 4. That's what we're integrating between. And this one's quite easy. It wants 5 ordinates, 4 strips. So it's just going to go 1, 2, 3, which is nice and simple. Sometimes it's decimals, but I like to see it like this. I like to sort of zoom in on the timeline, and this you'll see has 4 strips and 5 ordinates. So it's time to plonk these values into our actual equation to get y corresponding values. So y0 is the first x value, which is 0. So we're going to have 0 over 0 squared plus 2, which is just 0. Plus, and then yn is the final part, which is 4. So it's 4 over 4 squared plus 2, which is 4 over 18, or 2/9, you could simplify that to. That's the first bracket. Plus 4 lots of y1, in this case is 1, and 1 over 1 squared plus 2 is a third. And then you've got, it's not y2 next, because that's in this one, so it'll be y3 to do the next one, which is 3, it happens to be. So 3 over 3 squared plus 2 is 3/11. And then we've got plus 2 lots of, and the only thing left is this 2, and it's 2 over 2 squared plus 4, which is 2 over 6, which is a third. Now you'll notice all of this is in a huge bracket. There's a third times 1 is times by everything in this bracket added up. So make sure you use your brackets properly, and the brackets are in your formula booklet as part of the formula. And it's up here. Really there should be, I ran out of room, but there should be like another closed bracket there to close this one. And that was a common mistake that people made on this part, is sometimes they typed it into the calculator wrong. There's always some people who are going to type it in wrong and then not double check. I would advise you type it into the calculator twice and check you get the same answer twice. But some people actually didn't do the brackets right, and so they ended up timesing this third times 1 by only the first bracket, and that isn't right. You've got to times it by all of it. And you type that into your calculator, you get 1.104, and that's the fourth. The next problem is that it wants 4 significant figures, and some people put 4 decimal places. Just make sure you know which one's which. That's all the mistakes here. They're just silly little errors. Make sure you do the brackets properly, make sure you type it into your calculator twice, and make sure you give it to the right significant figures or decimal places depending what they ask for. So let's turn on to part B. So question 2, part B then. Part A was worth 4 marks altogether, I forgot to mention that there. So part B, show that an exact value to the same thing we had before is ln k, or natural log k, where k is an integer. Remembering the Simpsons rule is for an estimate. This question is asking us to express that it exactly is in the form ln k. So firstly we're going to have to integrate this. Now there's 2 ways you can do it. You can take a substitution where you could say u equals x squared plus 2, and you could go on and do normal integration with the substitution. But what I'm going to do is, when there's a form where the numerator is sort of the differentiated version of the denominator, so it's v dash, the differentiated version of the bottom, you can use a formula. That's quite a simple one. So if we differentiate the bottom bit, x squared plus 2, if we did do dy by dx of that, then you know we'd get 2x if we differentiated that just from your core 1 differentiation. So if we were to take out a factor of a half, so if we take a half outside of this integral between 4 and 0, x over x squared plus 2 by dx. So we've taken a half out, and that, if we take a half out of this, it just leaves x. So now, because this numerator is the differentiated version of the bottom, so if the bottom was f of x, the top is f dash x, then we can say that the integral, we take this half stays outside, what we're integrating now is natural log of the denominator, x squared plus 2, between this 4 and this 0 still. That's a 0, not a 6. Okay, so you could have used a substitution, and indeed quite a few people did. It was more common to see silly errors in this than it is in this one. If you use a substitution, more people made silly mathematical errors than when they did this method. But that's not the part where most people tripped up this bit, it's the next bit. So we know we have to put in the 2 values. You keep your half outside for the minute and sort of do a big bracket. And in the first one we have the natural log, and we put 4 in first, so 4 squared is 16 plus 2 is 18, so we have the natural log of 18, that's our first bracket, minus the natural log of x is now 0, x squared is still 0 plus 2 is 2, so it's natural log 2, all inside this massive bracket. This is where most people lost the marks. Some people left it like that and didn't know what to do. If you've got natural log of one thing minus the natural log of the other thing, then that's the same, keep the half outside for a second, that's the same as the natural log of the first one divided by the second one, so 18 over 2, which is 9. Okay, so that's just one of the logarithmic rules. The first one minus the second one, you can divide it, and it's the same as your log rules back in core 2. The natural log rules work in the same, and some people forgot that from core 2 or core 3, and they didn't do it and they left it in this form. So that's somewhere a lot of people tripped up. The next thing people did is some people got this part, they remembered that rule, and then left it like this. There's another rule that says that that is the same as the natural log of 9, and that 9 is to the power of a half. There's another rule that says you can take the coefficient of a natural log and put it up to the top like this. And once you get that, you should know that 9 to the power of a half is just 3, it's just the square root of 9. So it becomes natural log 3. And this altogether was worth a whopping 5 marks. So let's quickly reiterate what's happened in this question. Now, you could have used the substitution, but we're ignoring that because I didn't do that in this method. I said that because the numerator is f dash x compared to the denominator, which is f of x, in this case. So the top, if you differentiate the bottom, you'll get it into the top. If we take out this factor of a half, then we can go straight to putting it as natural log of this. So that's what I did, and some people didn't do that right. But then some people, more commonly, didn't remember these silly little rules down the bottom. So one minus the other, you can divide, and the thing is a coefficient can go up as a power, as the number. They're just two simple rules, but if you forget them, you can't get past this stage. And this line and this line are 2 of the 5 marks straight away. This being the 5th mark because it's the answer. This is one of your method marks for going about it in the right way, remembering this rule. Getting to this stage would have got you the 3 marks previously. Getting to this just like this, and the integration itself actually got 2 marks, because you could get a mark if you omitted this half. You didn't do the half. You forgot that differentiating that would get 2x, and if you said, well, that's just the same as x, which is a silly thing to say if you think about it for a second, but you would still have got a mark for doing that and omitting this half, and you get 2 marks if you remember the half. Then your 3rd, 4th and 5th mark. So altogether this question was out of 9. It sort of balances between who struggled and who didn't. Hope this helped at least a little bit, and let's get on to question 3.